Good evening, everyone. We are in the week 6 problem solving session of the NPTEL course Basic Electrical Circuits, and week 6 is about circuit theorems and two-port network. Let me share my screen. So, in the last week, we have discussed few circuit theorems, and today also we'll be discussing few more circuit theorems, mainly the Thevenin theorem, Norton theorem, and maximum power transfer theorem. And then we'll go to the two-port networks. But before that, I'll just quickly summarize Thevenin's theorem, Norton's theorem, and maximum power transfer theorem, and then we solve few problems on this, and then we'll move to two-port networks. So, in the first, we'll start with the Thevenin's theorem. So we have Thevenin's theorem. So first of all, it is only applicable with circuits with independent voltage source and linear components. So any circuit with independent voltage source or current source, so I would say any circuit with independent sources and linear components can be expressed as a series combination of voltage source and a resistor. So we'll see how and what is that. So any circuit with independent sources, independent sources and linear components. So as far as this syllabus is concerned, as this course, we are considering resistors and dependent sources. We are not considering capacitance and inductor, although they are linear. But in this course, as far as the syllabus is concerned, we are only covering resistors and dependent sources. Okay. So any circuit with independent sources and linear components can be modeled or can be modeled as a series combination. So this is very important. So in Thevenin's theorem, it is series, and Norton's theorem, it will be parallel as a series combination of voltage source, which is VTH, and a resistance RTH. Okay, so let us first draw a circuit. So let me consider one circuit. So this circuit will have some independent sources plus some linear components. And say it has two terminal and they're named 1 dash. So in such case, this can be realized as a circuit with a voltage source VTH and a resistor RTH. And these are the same terminals. So the entire circuit is converted like this. So this is, let me draw it at the center. So this resistor is VTH and this is RTH. So the entire block we have basically drawn in this. So this is the previous block. So this can be now simplified. So the entire complicated circuit is now or can be realizable or can be converted and can be modeled as a simple circuit with one voltage source and one resistance. So now if something is connected here, we can just use this circuit because it is very simple. Only two components are there. Here it can be n components, 10 components, 100 components, but it can be formulated something like this. So first we'll check what is VTH. So VTH. This is also called as Thevenin voltage. So how do we find Thevenin voltage is the voltage obtained across the two open terminals 1 dash. So I'm using a different color, two open terminals. So now first we'll measure the voltage across 1 dash, and that voltage we'll call it as VTH. And how do I find RTH? RTH, it is called as Norton, or sorry, Thevenin resistance. I hope you are following. Is everyone following? Hello. Hello. Am I audible? Yes, sir. Yes. Okay. Resistance at the two terminals. So what is the resistance across those two terminals? 1 dash. When no voltage source is considered in the circuit. So whatever independent sources are there inside this, that needs to be ignored. Then what is the effective resistance? That resistance is called the Thevenin resistance. Resistance at two terminals, 1 dash, considering the independent sources, independent sources equals to 0. So if there is any voltage source, we'll short circuit. If there is any current source, we'll open circuit. So this is a very simple theorem. We'll solve one problem and understand how it is being used. So Thevenin's theorem, any circuit with independent sources and linear components. So if any circuit is there with independent source and linear components, say these linear components are resistors and dependent sources, then this can be modeled as a series combination of voltage source VTH and a resistor RTH as shown over here, where VTH is Thevenin voltage and it can be obtained as the voltage across these open terminals. So this should be open, and this open circuit voltage is called Thevenin voltage. And the Thevenin resistance, it is the resistance seen across these two terminals, considering the independent sources to be 0, which means voltage source will be short circuited, and the current source will be open circuited. So before we go into Thevenin's theorem, let us just quickly solve one problem. So I'm considering this. So they are asking in this question, what is the VTH in the circuit? And in the second question, they have asked some other question. So let us just quickly solve. So the circuit is simple. Basically, we should understand what they are asking and what we have to do. So I'm solving the problem just after the concept so that you can easily understand, and it will be, I felt this would be more effective than solving all the problems at the end. So that's why I have considered a different way of solving. So this will be our problem one for today. Okay. So now this entire thing is a box. So how will I find VTH? VTH is the voltage obtained across the open terminal. So this one dash are open. So now I have to find the voltage across this. Then I will get VTH. And how will I get RTH? By considering all the dependent sources to be 0 and find the resistance across these two terminals. That will give my Thevenin resistance. Okay. So first let me just solve directly and find the VTH. So let us just quickly draw the circuit. And so now the voltage across this is VTH. So the voltage, sorry, I'm really sorry. So the voltage across the plus and minus is my VTH. Okay. So I have to find the voltage across the current source. So I'll apply simple KVL. Okay. And how will I do that? This is my current, right? So the current is flowing like this. So the current is flowing like this. So if I call this I can write my I is equals to 60 micro Siemens into Vx. Okay. So this is my I. And what is Vx? Vx is the voltage at this point and at this point. So I am free to consider this as ground. So now my Vx is, how can I obtain Vx? By applying KVL. So we are going in this direction from which point. So I'll use a different color. So we have starting at this point and we are ending at this point. So if I apply KVL, I'll get Vx is equals to plus 2. Then because I'm going to a higher potential here, then I'm going to a lower potential. So minus current I into resistor 50K. Agree? Is it clear until this point? If you have any doubts, you please ask. If you are more interactive in the problem solving sessions, then it will be more helpful to you. And also, if you have any doubts, these sessions are basically for doubts. This is not another lecture session, so this has to be more interactive. If you ask, answer, then you will feel more confident. And if you make mistakes, then you can correct that mistake here itself, not in the assignment. So if you make a mistake in the assignment, your marks will be like reduced, and then you will realize that mistake later. So try to use this problem solving session as much as possible and make these sessions as effective as possible. So now I'll substitute I value here, right? I can do that, or anyway, it is fine. So if I do that, I'll get Vx is equals to 2 minus 60 into micro, right? 10 to the power minus 6 into 50 into 10 to the power 3 into Vx. Agree? So now I have to solve for this. So Vx is equals to 2 minus. So what will be the value of this? Can anyone tell me the multiplication? 60 into 10 to the power minus 6 into 50 into 10 to the power 3 into Vx. I have just substituted I there. So anyone? 3. Yes. 3 Vx. So this is what we got. So let me just write. So this equation is given because they have given, and this is obtained by applying KVL. Okay. So now can you tell me what will be the value of Vx? Anyone? So someone said, sir, it is 60 millisiemens, not in ohm. Yeah, very good question. So now if you see, it is not in ohm. So I is 60 Siemen into voltage, right? So now here I is 60 Siemen into voltage. Now it is multiplied with a resistance. So Siemen multiplied by ohm will get cancelled because Siemen is ohm inverse. So now we'll get only voltage. So that's why it is all matched in the voltage. Is that clear? Whoever has asked? Roshan Ghosh, because we are multiplying with another ohm, so those two will get cancelled and dimensionally it will be still voltage. So someone has mentioned Vx is equals to 0.5 volt, and you are right. So Vx is equals to how much? 0.5 volt. So this is my initial Vx value. So now if I know Vx, I know I. What will be my I? I is equals to 60 microsiemen into Vx, which means it is 30 microsiemen. So now what will be VTH? Again, now I'll start from this point and I'll end at this point. So now my VTH can be written as VTH is equals to plus 2, then decrement 50 kilo ohm into I, and again minus 150 kilo ohm into I. Agree, everyone? Any any doubts or any confusion? Any questions? Sir, are you considering the 2 volt 50K and VX as one mesh? 2 volt 50x. No, I am not considering Vx. I am, see, this is, there is no mesh. Vx is just a voltage here. So I have started here and I have applied KVL to get this voltage. So from here I have started. So in order to go here, I have seen there is an increment in the potential of 2 volts. So if it is 0, this will be plus 2. If this is plus 2, what will be Vx? 2 minus current into this resistance will give Vx, because Vx is at a lower potential. So 2 minus the current into ohm will give me Vx. Vx is just the voltage in between these two resistors. It is not a mesh, but I am applying KVL in order to go there. Is that clear? Whoever has asked. Okay, sir. Yeah. So now I got this expression for VTH. So if I do that, I'll get 2 minus 200 kilo ohm into I. I is what? 30 micro Siemens. So microsiemen into Vx. So it is microsiemen into voltage V. So if we write that so that there will not be any confusion. So microsiemens into voltage. Okay, so now this will be 2 minus 200 into 10 to the power 3 into 30 into 10 to the power minus 6. So can someone tell me what will be the value of VTH? Just calculate and let me know what you are getting. So someone has mentioned minus 4, Bhuvan. So please check others if you are getting the same voltage or you are getting some other voltage. So this now I got my open circuit voltage, which is the Thevenin voltage minus 7. Tulasi, this will be 2 minus 6. So it will be minus 4. Just check your calculations and let me know whether it is matching or not. So this is my Thevenin voltage, right? So VTH is minus 4 volt and it is Thevenin voltage. So let us go and check whether it is matching or not. VTH is minus 4. So it is matching. Now let us go back and see what they have asked in the second problem. So second problem they have asked if any load is connected over here, what will be the maximum value of load such that maximum power is dissipated in it. Okay, but before going to that problem, first we have to find out RTH. How will I find RTH? RTH is found, let us go back, by considering independent sources to be zero. So I'll short this because it's a voltage source and everything remains same. So let us just redraw it to calculate the Thevenin resistance. So there is one 50 kilo, there is one 150 kilo, and there is one current source in the downward direction. And then I have to find the voltage across it, right? So I'll consider one voltage source and what I'll do, I'll call this as V test. And if it is generating I test, then I know my RTH will be V test by I test because the voltage by the current it is applying, it will give my R Thevenin. Okay. So that's what we are going to do. And everything remains same 50K, 150K. So this is 50 kilo ohm and this is 150 kilo ohm. And this is plus minus Vx and 60 microsiemens Vx. So this is plus minus Vx and this is 60 microsiemens into Vx. So now if you see, let us apply KCL here. If this is I test, so I need an equation in terms of V test and I test so that I can get R Thevenin. So what we are going to do is, uh, first we'll apply KCL. So let us assume the current is entering and the current is leaving. So now if I apply KCL, I'll be getting current entering I test is equals to current leaving, which is 60 microsiemens into Vx, and let this current be I. Okay, plus I. So this let it be my equation 1. So now if the current is I, what will be the value of Vx? Vx is nothing but, let us assume this as a ground because that makes our life easy. So now Vx is nothing but 50 kilo ohm into I. Agree, everyone? Sir, test voltage considered only when we have dependent source. No, no. Test voltage we are considering to find RTH because say this, how do I find the impedance across this current source? I cannot do that, right? Like if what will be the effective resistance across these two terminals? So these are my 1 dash terminals. So how will I find the resistance across these two terminals, which when there is a current source? I cannot do that, right? Because I can neither I can neither short the current source because it's a dependent source, nor I can open it because it's a dependent source. I cannot do anything. So how will I find the resistance? It is not so straightforward. So we'll consider one voltage source, test source across those two terminals, and we'll assume that it is drawing a current I. So if it is drawing a current I and its voltage is V, then the resistance is across these two terminals is V test by I test. So that's why we're considering these two, which are unknown, and we need the ratio of this. So from there we can actually get. Is that clear? Okay. Someone has said, okay, sir. Yeah. So now Vx is equals to 50 kilo ohm into I. I hope this part is also clear. So now if I substitute, I will get Vx is equals to 50 kilo ohm into I is what? I test minus 60 microsiemens into Vx. So my Vx is nothing but how much? 50 kilo ohm into I test minus 3Vx. Agree, everyone? Hello. Is this calculation clear to everyone? Yes, sir. Okay. So now, yes, sir. So now I will get 4Vx is equals to 50 kilo ohm into I test. Right. So let me just go. So let this be an equation. So this is one equation. So now what do I need? I need V test in terms of I test. Then I can get the RTH, right? So do you agree that this voltage is, let me use a different color. Do you agree that this voltage is V test? If that voltage is V test, I will apply KVL in this way to get the value of V test. So what will be the value of V test? V test is equals to, what will be the value? 50 kilo ohm plus 150 kilo ohm into I. Agree, everyone? 50 kilo ohm plus 150 kilo ohm into I, which is what? 200 kilo ohm into I. Agree, everyone? I have just applied KVL in this way and I have calculated V test in terms of this resistance multiplied by current. Simple and straightforward. Uh, Everyone agree? Yes, sir. Yes. Okay. So now if you see, I will use this. Okay. So if you substitute this, so if you substitute this in this equation, like the value of I, what will you be getting? You will be getting V test is equals to 4Vx, isn't it? You people agree? Or any doubts? I have just used those two equations to get yes. Now, so now we know that 4Vx is nothing but 50 kilo ohm. So from these two, so from these two equations, you will be getting V test is equals to 50 kilo ohm into I test. So now I will get my R Thevenin is nothing but V test by I test, which is nothing but 50 kilo ohm. Agree? Sir, once again, repeat how to find the R Thevenin procedure. Sure. So, I'll explain the entire problem again. So whoever has come late, they will also be able to understand. So we have discussed about Thevenin's theorem. So we have to first find Thevenin voltage and Thevenin resistance. For finding the Thevenin voltage, it is the voltage across these terminals 1 dash and they are supposed to be open because that's how it is defined. So for calculating this VTH, first what we have done, we have seen that this current is nothing but 60 microsecond into Vx, and then we have found Vx, which is 2 minus I into 50k. By substituting this, we got Vx, and if we substitute this Vx in this first equation, I will get my current I. Once I get my current I know that VTH is nothing but 2 minus 50 kilo into I minus 150 kilo into I. By substituting the value of I got VThevenin to be minus 4 voltage. And we have also checked that it is perfectly matching with whatever answer they have given. So that completes our first part, which is the Thevenin voltage. Now for the second part, I have to find the resistance across these two terminals. But how will I find the resistance across these two terminals? There is a current source, right? I will not know what is the value of resistance. So in such circumstances, what we do is we assume that there is a voltage source. we are connecting a voltage source and we are assuming that it is drawing some current. So now the ratio of this V test by I test is nothing but the RTH, right? Because if we consider if we consider this entire thing as a resistor RTH, then what is my V test? R Thevenin into I test, right? So that's what we are using over here. So that entire thing is replicated as a R Thevenin, and we have to calculate the ratio of V test and I test. So for that to be done, we need a equation in terms of V test and I test. So first I have started that with the KCL. I have applied KCL over here and I have calculated the value of I. Once I know the I know Vx. So Vx and I relation is obtained and I have substituted the value of I, and then I got a relation between Vx and I test. Now I have to find a relation between Vx and V test. So once I substitute this, I'll get the ratio of V test and I test. What is the value of V test? V test is nothing but this entire resistance into current. Entire resistance into current. I have substituted the value of current. Then I got V test in terms of 4Vx. Then I have substituted this in this equation, which gave me my RTH, which is also the Thevenin resistance. Is this part clear? How we have solved Thevenin resistance? Is it clear to everyone, whoever has asked? Lokesh, I hope this is clear, or if you have any doubts, you can ask. Any doubts, anyone? Until this point? Hello. Sir, how can get notes that you have solved? So, whatever notes that I am giving, or whatever lectures or the recording that we are collecting today, all will be uploaded in my YouTube video, as well as I'll upload this to my Google Drive. So this information I have already shared earlier in my chat. So let me just quickly go back to my earlier chat and share the links. So let me just quickly go back. I have mentioned somewhere uh, in this chat. So once you go back, you can find it, or let me just quickly go back and see. If anyone finds out, just mention in the chat so that everyone will be helpful. I'm just going back. Yeah, I found it. So I'm mentioning three links which are same throughout this entire session. So one first link is my YouTube channel where I'll be uploading these videos, and link to Zoom meeting, this Zoom meeting where we'll be conducting the sessions every week. And the other one is Drive to access the notes where I'll be uploading my weekly notes. And someone has mentioned, sir, one more doubt, one more question. Bhuvan, can you ask? What is your query? Hello, Bhuvan. Okay, if you have doubt, you just mention because I'm not able to hear. Or you can just unmute yourself and you can ask the question. Okay, but before we proceed, I think he has asked. Sir, can you explain one more question? Yes, sir, getting 75% in assignment okay or performing poor? 75% is decent, Roshan, and it will be, I think, good. 75% is decently good. It is okay. It is not poor because they are not so straightforward assignments. So 75% is really good. Sir, can you explain one more question? Yes, we'll be solving few more questions, and I'll also go to Norton, and then we'll proceed to two-port networks. So they have also mentioned how to find the maximum power. So this is the overall equivalent circuit, right? So if this is the circuit, say we have a voltage source. So this now we are discussing maximum power transfer theorem. Maximum power transfer theorem. So what does it say? So in a scenario like a Thevenin equivalent circuit scenario, if there is a load resistor connected here, okay, then power, the maximum power is transferred to the load resistor RL when RL is equals to R Thevenin. So this is a result of what you will be getting once you prove it, but the proof sir has explained, so I am skipping. I'm only discussing the result. You can also prove, calculate the power across this and then differentiate it with respect to RL. Then you will be getting this expression. And the power, maximum power P, maximum power that is delivered will be V Thevenin square by 4 into R Thevenin. So this is what you will get once you calculate it. So if you calculate it, this is what you will be getting. So in the question, they have asked what should be the load RL such that the maximum power will be transferred. So what will be the value of RL? It is just R Thevenin. And how much is the R Thevenin that we are getting? 50 kilo ohm. So this will be my RL. So maximum power condition is RL equals to R Thevenin, which is 50 kilo ohms. So load resistor of 50 kilo ohms should be connected in order for it to get maximum power. So which is what they have also written 50 kilo ohms. So is this part clear until this point? So we have discussed Thevenin's theorem as well as we have quickly solved few problems. I mean one problem on Thevenin's theorem. Now we'll move on to Norton's theorem, which is also quite similar to this. But before that, any questions? Anyone? Hello. Any questions? I hope it is clear. Or do you have any doubts before we move into Norton's theorem? Clear, sir. Okay. So I'll just correlate directly with Thevenin's theorem and Norton's theorem. So let us use the same. So I have this habit of using the same so that once you correlate, you can easily see. So the color combination, everything will remain same, and you will know where the difference is between these two theorems and what we are actually changing. So this is Norton's theorem. So everything remains same. Any circuit with the independent sources and linear components can be modeled as, instead of series, we'll get parallel combination. So it will be parallel combination of voltage source. Instead of VTH, we have V Norton. RTH, we have R Norton. So everything remains same. So this will be V Norton and R Norton. So if this is the circuit, so how it is going to be? So here we have current source, right? And it is no more series, it will be parallel. So let us draw. So we have a current source and then we have a Norton resistor in parallel. So this will be my I Norton and this will be my R Norton. And one thing you have to understand that both the theorems are almost same. Only the representation is different. Here it is series and VTH RTH. Here it is parallel and it is I Norton and R Norton. So now we'll see, we have already seen how to calculate Thevenin voltage as well as Thevenin resistance. Now we'll see how we'll calculate Norton current and Norton resistance. Okay. So let us use the same color combination so that one can see what is actually getting changed. So we have two voltages. One is, I mean, two parameters, V Norton, R Norton. So this is called as Norton voltage. This is called as Norton resistance. I'm sorry, it should be current source. So this is IN because it is current. So someone has asked, sir, why we are taking current source instead of voltage source in the Norton theorem? So basically, Thevenin theorem converts the circuit into a voltage source equivalent circuit. So it has voltage source and a series resistance. This voltage and series resistance can also be converted into current source and resistance. So if you want to convert some circuit into uh, voltage source, it has to be used through Thevenin theorem, one voltage source and in series with a resistor. If you want to convert into a current source, then it is converted using the Norton's theorem. So we have a current source as well as a resistor. So basically, both are more or less same, and we can also get the relation. Let me just write it. So Norton it will be current, right? So it is Norton current and Thevenin resistance. So it is the current obtained through the, so it is a current obtained or current flowing through the two short terminals. So we have to short it and then calculate the current, two short terminals. And Norton and Thevenin resistance both are same. Only we are writing it as Rn and Rth, but both are same. Kindly note that. So we have R Norton is same as R Thevenin, but they are just using a different notation. There is less than a minute. If this meeting ends, kindly join back. So there is a correlation that you can get. Let me just use it. If this meeting ends, kindly join back. Then we'll understand Norton's theorem and we'll solve one problem. I think this meeting will end soon. Kindly join back. So this is Thevenin and this is Norton, right? Are you following, everyone? I think this meeting will end soon. Kindly join back so that we can continue our discussion. So this was our Thevenin's equivalent. This is our Norton's equivalent. Right. So first of all, both are same, right? We are using some different theorem to get this like what? Sorry, this there is some spelling equivalent. So basically, we are using two theorems to get two different equivalent circuit of a given circuit, and we have seen that R Thevenin is same as R Norton. Right. So now say one dash is open. Say one dash is open. So we are saying one dash, no load is connected. No load is connected. Then what will happen? There is no current flowing, and here also the current flow will be zero, and here also all the current will flow through the R Norton, right? But irrespective of the method, V11 dash voltage should be the same. So I'm sorry. So V11 dash using Thevenin's theorem, what will be the voltage? VTH, because current is not flowing. So whatever is the voltage here, it will be also the same here, right? Similarly, what will be the V11 dash in this case? Rn into Rn, right? In into Rn. So here V11 dash is nothing but In into Rn, but In and Rn and R Thevenin are same. So I am writing it as In into R Thevenin. But the thing is, these two are should be equal, right? Because we are using a same circuit, even though we are using two different theorems, but the voltage should remain same because it's the same circuit. So these two are equal. So now what we'll be getting? We'll get something like this. V Thevenin is equals to I Norton into R Thevenin. So once you calculate VThevenin and RThevenin, I can get I Norton current by doing VThevenin by RThevenin, and I Norton is same as RThevenin. So if you get Thevenin's equivalent, you can convert into Norton's equivalent. If you get Norton's equivalent, you can get into Thevenin's equivalent. So let us understand this. Here we got VThevenin as minus 4, right? So VThevenin minus 4 and RThevenin 50 kilo. So let us use the same example. So now I am calling it as problem 2. Problem 2. So our equivalent circuit is something like this. Are you following? I hope that whatever I have told was understood. If you have any query, please ask. Don't hesitate. VThevenin is minus 4 volt and RThevenin is 50 kilo ohm. Now we are going to convert this into Norton circuit, which is something like this. The same 1 dash, and we want I Norton, and R Norton is same as R Thevenin, so it is 50 kilo ohm. And what is I Norton? I Norton is nothing but VThevenin by RThevenin. So we have minus 4 volt by 50 kilo. Can someone tell me in terms of micro what this will be? I Norton in microamperes, 50 kilo ohm. Anyone? 80. Yes, Bone, you are right. So this is minus 80 microampere. So current in the upward direction is minus 80. So I can redraw this as something like this. So we have current in the downward direction and one resistor, and this is 1 dash, 1 dash, and this is my 80 microampere, and this is my 50 kilo ohm. So from Thevenin equivalent, we got Norton equivalent by using the result that we have obtained over here. So is that part clear? How to change from Thevenin to Norton, Norton to Thevenin? Same thing we can do. So if we have this circuit, IN is minus 80 and R Norton is 50. How will I get VThevenin? 80 micro into 50k minus 80. So it is minus 4 volt, and it will be in series with the Thevenin resistor, and we'll be getting 50 kilo ohm. Is that part clear? Everyone? It's just source transformation. Yes, you can say that. I have not used that word because sir has not taught in the course. So if I use, some people might get confused, but Roshan, you are right. It is just a source transformation. You are absolutely right. Kindly check the voltage polarity. Voltage will be plus on the top and current is a source, not sink. So it will be from bottom to top. Voltage could be negative, current could be negative. It means it is the other way around with the positive magnitude, but kindly follow this convention, and voltage could be negative, current could also be negative. So now we have solved one Thevenin circuit, one Thevenin to Norton circuit. Now we'll directly solve one Norton circuit. So they have given one circuit where we have to find I Norton. So let us just consider this as problem 3 for today, and let us see how to solve this. Okay. So this will be our problem 3, and we'll see how to calculate Norton. Thevenin and Norton resistance are same, so you know how to calculate. But for calculating Norton current, we have to short circuit this 1 dash and see what is the current flowing through the terminals. That will give us I Norton. So basically what I'll be doing is, I'll short this. I'll short this. And what is the current that is flowing through this? That will give me I Norton. So it will be in the downward direction. So that is my I Norton. So I have to calculate that. Okay. So we'll start with the KCL. So first of all, let us assume this as ground. Okay. Then this is what is the voltage of this? 32 kilo ohm into Ix, right? voltage. Agree, everyone? Or do you have any doubts? Hello, everyone? I am considering this as ground, so there is one dependent voltage source. Sir, can it be solved by mesh? Yes, you can solve by mesh, but if you do mesh, you have one known current, two unknown currents. But now I'll solve using nodal analysis because only one node voltage is unknown. Using mesh, you have to solve for two equations, two unknowns. If I use nodal analysis, then I'll get one equation, one unknown. So that's why I'm proceeding with nodal, but you can use mesh analysis. So sometimes it's like which will save more time and which will simplify the maths. So you can do by mesh if you are comfortable by mesh. There is no harm in that. But if you do nodal, things will get simpler. So I know the node voltage. So I know this node voltage. So I can get the current flowing in this direction. And they have already given the current flowing in this direction. So if we apply KCL, I'll get 5 milliamperes is equals to current leaving, which is that node voltage 32 kilo ohm Ix by the resistance 8 kilo ohm plus Ix. Agree? Because this node voltage is 32 kilo ohm Vx. So current entering equals to current leaving. Yes, sir. So now if I see, you will get 5 milliampere is equals to 4Ix plus Ix, which means I'll be getting Ix as 1 milliampere. So one equation only I got the answer, some answer. So that's why I have applied nodal analysis because I saw there is only one unknown node voltage, whereas there are two unknown mesh currents. So that's why I did not choose mesh analysis. So Ix, is that part clear? Everyone? Hello, whoever is there. So Ix is obtained. Now what will be that node voltage? Say I'm calling it as V node Vn. That is 32 kilo ohm Ix, which is 32 into 1 kilo into 1 milliampere. So it is 32 volt. Agree? Now I'll apply KCL here. Current flowing, current entering equals to current leaving. So current entering is Ix. Ix is equals to V node voltage by 2 kilo ohm plus I Norton. So now I'll be getting Ix is 1 milliampere is equals to V node is 32 by 2k, 32 kilovolt 2k plus I Norton. So can someone tell me what will be I Norton? What will be I Norton? Simple calculation. Minus 15. Yes, minus 15 milliampere. So my I Norton is equals to minus 15 milliampere. So this is my Norton current. So once I get Norton current, I'll do Norton resistance, which is also same as Thevenin resistance. So I'll first check Norton is minus 15. So if you see, I Norton is bottom to top and its value is negative, which means the current is actually from top to bottom. But you have to see whether they have asked I and magnitude or is the direction same? Yes, it is same. So that's why it is minus 15. Then also they have asked what is the value of RL if it is connected. So as R Thevenin is equals to R Norton, so R load will also be equal to RL because we have seen that in this case, if a load is connected, the maximum power will be transferred when R Thevenin equals to RL. So even in this case, the maximum power will be transferred when RL equals to RL because both the resistors should be same. So then we have to calculate what R Thevenin. So for calculating R Thevenin, what do? We connect a test voltage and we see what is the test current and we have to find the ratio of that. But if you see, we have to consider independent sources to be zero. As there is only one independent source, which is current, we'll open circuit. So we have resistor, dependent source. So 8K and 2K. So for calculating the Thevenin resistance or Norton resistance, we have 8K here, 2K here, and then plus minus here. And we are connecting one V test and we'll calculate the I test. So this is my V test with a current I test. And this is how much? Let us see. 8K, 2K, 32K into Ix. 8 kilo ohm, 2 kilo ohm. This is 32 kilo ohm into Ix, where Ix is in this direction. So again, mesh analysis you can do, but if you see there is again one unknown node voltage, so it makes our life simple. If I consider this as ground, I know this voltage, node voltage Vn. Say let this be the current direction. So I can get V node voltage as V test plus 32 kilo ohm into Ix. Agree, everyone? Any doubts? It is just two voltage sources in series, so it will be summation. Any other doubts until this point? Should I proceed further? Hello, whoever is there, please respond. Okay.
Yes, sir.
Mad, yeah, okay. So now I'll apply KCL at that node. So current entering must be equal to current leaving. So current entering is Ix plus I test is equals to current leaving, which is Vn by 2 kilo ohm. Right. Sir, can you please explain this problem one more time? Okay, let me just quickly solve, then I'll come back and I'll explain. But as we are in between, first let me complete it, then I'll explain the entire question again. Okay, so we got one equation, second equation. Third equation, how will I get? I'll get the value of Ix. Ix is equals to 0 minus Vn, which is minus Vn by 8 kilo ohm. True? In is this. Ix is minus Vn by 8K. So first what we'll be doing is we'll substitute this in this expression. Okay. Then I'll get what I'll be getting. I'll get basically we have three equations. We just have to manipulate with that. Ix is equals to minus of V test plus 32 kilo ohm Ix by 8K. So if I do this, I'll get minus V test by 8K minus 4Ix. So from this, I'll get Ix to be minus V test by 5 8s are 40 kilo ohm. Agree? Hello, agree? Are you following? Okay. Sir, please repeat. Okay. So I have connected one voltage source and I have to get the relation between V test by I test because that is the R Norton is what V test by I test. So I have to get this. So what I did is I got this node voltage which is V test plus 32K into Ix. So once I got this, I have applied KCL, which is Ix is plus this current I test is equals to this current, which is Vn by 2 kilo ohm. And then I calculated Ix, which is minus Vn by 8k. So first I have substituted this Vn in this equation. Then I got the value of Ix directly, minus V test by 40k. So now what I'm going to do is, because Ix is equals to minus Vn by 8k and Ix is this, using these two, I'll get Vn. So what is my Vn? Vn equal to minus 8k ohm into Ix. So if you substitute this in this expression, and I have used this equation, so I will be getting Vn equal to minus V test by 5. Agree, everyone? How we are getting Vn and Ix? Okay, yeah. So now what we are going to do is, now first I'll use this equation, which is this Vn equal to V test plus this. So I have this equation, and I have this equation, and I have this equation as well. So you substitute Vn and Ix, and we'll see what we'll be getting. Sorry, we have to substitute in terms of I test also, because we don't know what is I test, right? So I need to find out what is I test. So how I am going to find I test is, I think I have made one mistake. Vn plus, this is I test, right? Sorry, this is I test. So I have to substitute in this expression Ix plus I test. So this is the expression where I have to submit this. Yeah. So this is the expression by applying KCL. So now we'll use these three equations and we'll see what we'll be getting. So Ix is nothing but minus V test by 40 kilo ohm plus I test is equals to Vn, which is minus V test by 5 to 10, right? 10 kilo ohm. True? Agree? Are you following? Hello? Hello, is everyone following? No, no answer. Yes, sir. Okay. Confusing, sir. Okay, okay. Let me just come back and see. Basically, I have one circuit. I have to calculate V test by I test. So I need to get a equation where I'll be getting V test and I test. So what we have done is, first this voltage is there, right? 32k into Ix. So this voltage source plus this voltage source is Vn. So Vn is nothing but V test plus 32 kilo ohm into Ix. Then I have applied KCL here, which is Ix plus this I test is equals to the current flowing in this, which is Vn by 2 kilo ohm. Okay. Then Ix is nothing but 0 minus Vn by 8 kilo ohm. So first what I have done is I have substituted the value of Vn in this expression. So I get Ix is equals to minus of Vn, which is V test plus 32 kilo ohm by 8k. If I do the simplification, I'll be getting minus V test by 8k minus 4Ix. So from this, I'll be getting Ix equals to minus V test by 40k. Is this clear? Please also check the calculations, because no one is responding. Is this part clear? Ix equals to minus V test by 40 kilo ohm. Yes, sir. Okay. Okay. So Ix is minus V test by 40 kilo ohm. Now Ix is also minus Vn by 8k. So Vn is minus 8k into Ix. And Ix is minus V test by 40k. So if I do this, I'll get Vn is minus V test by 5. Agree? I have used the third equation and this equation. Yes, sir. Okay. Yes. Okay. So now I'll write the second equation, which is Ix plus I test equal to Vn by 2k. And these two boxes, which is X equal to minus V test by 40k and Vn equal to minus V test by 5. So these are the three equations. Let us substitute these two. So Let us substitute this in this equation and also this in this equation. So I get Ix, which is minus V test by 40K plus I test equal to Vn by 2K. So is this clear until this point? How we are getting? Mainly we removed Ix. Yes, we have removed Ix as well as Vn. So now if you calculate, I test is nothing but V test by 40K minus V test by 10 kilo ohm. True? Agree? Yes. So now, what will be the simplification? Yes, sir. So what will be the simplification? Anyone? One mistake I have done. It is minus 8 kilo ohm into Ix, right? So this is already minus. So minus into minus, there will be one plus. Kindly make sure this I have made a mistake. So this is plus V test by 5. So this also plus V test by 5. So this also plus and this also plus. So sorry for that. Because Ix is minus V test by 80K and Ix is minus Vn by 80K. So there will be one minus minus gets cancelled and Vn is plus V test by 5. So kindly note that I have made this small mistake. Yeah. So now if you add this, what we'll be getting? I'll be getting 5 V test by 40 kilo ohm. So now I need V test by I test, which is 8 kilo ohm. So that implies R Norton equal to 8 kilo ohm. So basically, in a given circuit, I have V test, I test unknown, as well as Ix unknown, and Vn also unknown. So I need to use these equations and make sure that I'll get one equation in terms of V test and I test. So that is the overall objective. So once I get this, I'll get V test by I test ratio as the resistance. So one thing we have to clear, see here I have one equation, two equations, three equations. So we have three equations, four unknowns. So what we will be getting? We'll be getting one equation with two unknowns, which is what I have done. So because we need only ratio. So that's why first Ix is in terms of Vn. So first you have to reduce one variable. First I have reduced one variable. Ix I got in terms of V test. Then I have to reduce the other variable, which is Vn I have also obtained in terms of V test. So now I have eliminated two variables. I have substituted it one of the equations to get one equation with two variables where we'll calculate the this Rn. So now once Rn is known, the maximum power will be transferred to this load when Rn is equals to RL. So which is what we'll be writing. Okay. So if there is any resistance connected over here, maximum power will be transferred when Rn is equals to RL. So that implies my RL equal to 8 kilo ohm. So that much resistance I have to connect for it to get the maximum power. Is this part also clear, everyone? So let us go check and see. It is minus 15 is the first one and 8 kilo ohm is the second one. So that part is clear? Yes, sir. So if you have any queries, you please ask me. I'll revise before we go into the two-port network, which is our today's final discussion. Any more doubts before we move into two-port network? So today we'll only be discussing Y parameters. Repeat again, sir. Okay, which part you want me to repeat again? The last problem or Thevenin or Norton or the entire part? Whichever one you want, I'll repeat. So if you want me to revise whatever we have discussed again, I'll repeat. Or if you want only the last problem, I'll repeat that. So let me know. Last problem. Okay. So in the last problem, they have given one circuit and we have to find I Norton and R Norton. So for I Norton, we know that it has to be shorted and calculate I Norton. So how did I do? First, I know this node voltage, which is 32K into Ix. So I have applied KCL at this node. So 5 is equals to this current plus Ix. So from this expression, I got Ix as 1 milliampere. So if I know Ix, I know this node voltage, which is 32K into Ix. So 32 volt. Now I have applied KCL over here, which is Ix is equals to Vn by 2K plus I Norton. So from this, we directly got I Norton and it is very straightforward. Coming to the R Norton, I have to find the resistance across these two
Sir, sir,
terminals.
sir.
Yeah.
Sir, how did you know the voltage 32 kilo ohm into Ix base, sir?
So if you come in this direction, so it is 0 and there is plus 32K into Ix. So this is 32K into Ix, right? So if you apply KVL in this loop from this point to the top point. So basically we went from here to here. Agree? It is just an increment in the
Yes, sir.
voltage source, right? Yeah. So now in the case of R Norton, we have to connect a voltage source and see what current it is drawing. So basically what happens is this entire part should be represented by a resistor R Norton. So I test is equals to V test by R Norton or R Norton equal to V test by I test. Now how many unknowns are there? Ix, V Norton, I test, V test. So we have four unknowns. We want equation with two unknowns, which is V test, I test. So I have to convert Ix in terms of one of these and Vn also in terms of one of this. So which is what I have done. First, I have written what equations I have. One equation is this node voltage, which is V test plus 32K into Ix. Other one is by applying KCL. And the third one is the value of Ix. So 0 minus Vn. So now let me not go into the calculations. You can do it by yourself. So I have three equations, four unknowns. First, you have to calculate Ix in terms of either I test or V test, and Vn in terms of I test and V test. So now once you get that, you substitute it in the third equation. Then you will get I test equal to V test by 8K. So V test by I test is nothing but 8K. So I will get R Norton to be 8K. So we have three equations, four unknowns. I need to convert that into a single equation with two unknowns. And they should be only I test and V test because I need V test by I test. So I have to eliminate Vn and Ix, which is what exactly I have done here. So is that part clear? Whoever has asked. Bhuvan?
Yes, sir. Yes, sir.
Yeah. So, and Yogi Bani, are you there? Are you following? Yes, sir. So, are you able to understand how to solve this? So, whoever I'm going to just tell you something. Whoever is going to or whoever is facing some issue in solving the assignments. So this is the things like that you have to follow and keep this in mind, things to follow. So first thing is, first thing is go through the lecture videos. All lecture videos you have to go through. You cannot skip this. This is a must. This is a must. So you have to go through all the lecture videos and sir is solving few problems in the lecture videos. Solve that problems by yourself. Even though sir has solved, even though you have watched the solution, again try that try to solve the problems by yourself. Try to solve the problems by yourself. So I know that even if you have gone through the lecture videos, there might be some questions or some confusion regarding some topics. So that's why I always try to revise the topics that sir has covered, assuming that few of you have doubts. Because if I directly go into problem solving session and solve problems, that I feel does not it will not be as fruitful as how I am doing now. So that's why I revise few topics and again I solve. So lecture videos is a must, and try to solve the problems by yourself. Okay. And the second part is problem solving session. I am not saying join my problem solving session. If you are fine, you can join. If you are busy, you can join the other problem solving session. But you try to understand how we are solving the problems. It's not that only I am solving and you will go through the video later. It is never like that. While I am solving, you also have to solve. So you have to solve with me. You should solve with me. If you realize I'm going a little bit fast, you can tell me that please solve it slow, or please explain, and I will always explain. You should solve with me. Then you will know what I am doing and how I am doing. So you can think, okay, if you are planning to solve in a different way, you can tell, sir, can I proceed in this way? So that is also okay, and you can solve. And even though I have solved, one thing you can do is you can again solve them later. You can again solve them later and see whether you are able to solve or not. As the solution is already on the YouTube, you can refer to my videos, but you try to solve them by yourself. So at this point of time, you have gone through lecture videos. If you have any confusion regarding the concept that has been already discussed in the problem solving session, so first of all, your concept is clear. Now coming to whether you will be able to solve the problems or not. First, you have solved the problems that sir has discussed in the lecture videos, and then you have attended one or maybe two or three problem solving sessions, and then you have solved the problems with the corresponding TS, me or the other two of the members. So you have tried to solve, and we try to solve as many uh, like concepts as possible and touch as many problems as possible in this 2 hour session. So as the concepts are Thevenin, Norton, maximum power transfer theorem, and two port, I have tried to touch all these except the two port till now, which I am going to cover after this. So I have tried to cover these each of the concepts. So I am trying to build your concept. So now uh, you have solved few of these problems only, not all, only few, but you have the questions and you can always come back and try to solve them by yourself. And after this, say you have only attended one session, one problem solving session, you have two other session and they are solving a different problems, not the same problem set. So you can refer to their videos. So you can refer to other problem solving session videos, other problem solving session videos, and solve few problems. It is not that you have to solve all the problems, because we might not also get that much time, and I know you have some other work. So it is not needed. Wherever you are feeling a little bit not so confident, those problems you can solve, and solve few problems. Where you are not feeling confident, solve few problems. And you already know the solutions are there in the videos. So don't look at the solution, look at the question, solve the question and see whether you are able to solve or not. If not, then look at the solution and see why you are not able to solve. That is the question, why you are not able to solve. See whether your concept is not clear, then again review the concept that sir has explained or one of the TS has explained, and see why you have not understood the concept. If you have any doubts, you can reach out to the TS, you can mention in the comment section why you are not able to solve. Okay. So now you got some clear concept understanding, and also you have solved few problems, right? Now what happened, you got the concept clear and you have solved few problems, and more or less you feel confident, but it does not mean that you will be able to solve each and every question in the assignment. That is understood. I'm also not saying that you will be able to solve, because there might be few tricky questions, right? So now comes the assignment. Assignment in the assignment, say you are able to solve 60%, say 60% you have solved. say 60%. Then after the assignment, once the key is released, you can see where you have done mistake, and then first try to again solve by yourself. First again solve by yourself where you have lost marks, again solve by yourself and see whether you have made any calculation mistake, any silly mistake or not. Say you are not able to resolve and you see that you are not able to understand why you have made a mistake, then you can refer to our videos where we will explain the solution, because we are informed to our videos where we explain the solution, where we explain detailed solution. Because we are explaining detailed solution, you can see why you have made a mistake and where you have made a mistake, and try to rectify that in the final exam. So identify the mistake, identify your, there is less than a minute. If this meeting ends, kindly join back. Identify your mistakes and rectify them in the future, because you first, the first part always be finding your own mistakes and then rectifying them in the future. First you have to identify why you have done wrong, where you went wrong, then you get the correct procedure, and then you will rectify them in the future. So this is how it goes. So I think this meeting will end, then I'll discuss about two-port network. For final exam, what else we need to solve apart from assignments? No, assignment should be more than enough. You can expect the similar questions in the final exam. So let me summarize. First, you have to go through all the lecture videos. You cannot skip it. It's a must. And try to solve the problems by yourself, whatever sir has solved. If you are not able to see, the solution is there, sir has clearly explained, then you can check. After that, you can attend the problem solving session, whichever you are available for. Could be mine or could be the other two TS. Attend at least one you should attend. If possible two, if possible three, but I know 3 into 2 6 hours is a little bit difficult, but you fix to any one of the problem solving session and must attend that session. And whatever problems I solve, you should solve with me, so that you can make mistakes, so that you will know, okay, I'm making mistake here, so that you can resolve them later. And say you are not able to solve few problems, then after the video is uploaded, you can go back to that video and solve the problems again by yourself and see whether you are able to solve them or not. If not, the solution is there, so you can refer to them. After that, you will get little bit confidence, but if you want to solve few more problems in the other problem solving sessions where the videos are already uploaded to the YouTube, you can go and solve few problems of those concepts where you are not that much comfortable. And if you are not comfortable, see why you are not able to solve, and the solution is already uploaded, so you can refer to them and you can improve your confidence. So once you have prepared well enough, then you will be finally solving your assignments and submitting the key. Say you have solved, I have considered 60%, say 60, 75, 70, 50, whatever. Once the key is released, see where you have made mistake and why you have made mistake, and again try to solve by yourself first. Because if you solve, then it would be easy for you to realize where you have gone wrong and why you have gone wrong. And if you identify the mistake by yourself, you will remember it forever. This I am telling from my experience, so you'll be able to remember it. Then if you could not resolve by yourself, then you can refer to our videos where we are explaining the detailed solution. And when we are explaining, you see why you have made mistake and try to rectify them in the future. Sir, can I send my doubt to you in email? Yes, you can send your doubts to the email. I'll try to reply in 24 hours because I also have my research work going on. So I'll try to reply to your mail. So if that is clear, we'll go to our next session. But before that, whatever I'm trying to say, is that clear? How you can improve
Yes, sir.
yourself? Yeah. Try to follow that and try to maintain consistency and try to do it every week so that your marks will improve. Sir, kindly give me your email ID. Yeah. Let me just mention in the chat box. So it is teja2281@gmail.com. So now we will be solving two-port networks. And today we'll be only discussing Y parameters. Y is like a conductance. Thank you. Okay. So now let me consider one two-port network. Okay. So this is our two-port network and it has four terminals. One is the input. Anything could be input, anything could be output. So that is one crucial thing. So say this is 1 1 dash and this is 2 2 dash. Say one terminal is input and one terminal is output. But irrespective of that, we are naming it as V1. Look at the polarity how we are using and currents entering be I1 and I2. So now if I write currents in terms of voltages, I can write it as I1 is equals to Y11 into V1 plus Y12 into V2. Similarly, I2, because it's a linear circuit, it can be written in a linear expression. So I1 will be a function of V1 and V2, and it will be linear, and I2 will be a function of V1 and V2. And note that this is linear. It is only applicable for linear. So linear means independent voltage sources are outside, so it will be resistors and dependent sources. Okay. Now I2 will be Y12, so Y21 and here Y22. So Y21 into V1 plus Y22 into V2. So it can also be written in terms of a matrix form. So we have I1 and I2. I1 and I2 is equals to we have Y11, Y12, Y21, Y22 in terms of V1 and V2. So people will be asking in the exam, find Y11 and Y12. So how will I find Y11? Y11, if I make V2 is 0, Y11 is nothing but I1 by V1, right? So that part, is it clear until this point? How, what are Y parameters and how we will write in terms of I and V voltage? Is this part clear or do you have any queries? Clear. So now how will I calculate I11? If I make V2 0, then Y11 is nothing but I1 by V1, right? So my Y11 is equals to I1 by V1 when V2 is 0. Is this part clear? Similarly, I can get Y12 as I1 by V2 when V1 is 0. Agree? I am just making one of them 0 and calculating the parameter value. So is that clear how we are doing? Yes, sir. Okay. Similarly, what is Y21? Y21 is I2 by V1 when V2 is 0. And then Y22 is I2 by I2 by V2 when V1 is 0. So this is the overall concept behind this and how we should be solving this. So is this part clear? How we'll be getting these parameters or do you have any doubts?
Yes, sir.
Yeah. So now we'll use this. So let me just draw this here. So we'll write in the same line close by. So we are going to use this to solve one problem to understand the concept. So let us solve this last problem. and this is the two port network. So this will be our problem for today. Okay. So this becomes our problem 4. So if you see, once we make V2 equals to 0, I can calculate these two. So if V2 is 0, then I can calculate Y11 and Y21. Similarly, if V1 is 0, then I can calculate Y12, Y12 and Y22. So first, we have to short on one side and calculate two parameters, and then we have to short on the other side and calculate the other two parameters. Is that clear, or do you have any doubts? Hello, hello. Yes, sir, clear. So as we are having only 30 minutes, I will solve only one side. So whichever one you want me to solve, which one you want to me to solve, I1 equals to 0, I mean V1 equals to 0 or V2 equals to 0. As this is a symmetric circuit, it will be the same. Meaning, even if I short this or even if I short this, it will be just vice versa. Because if you see, the circuit is symmetric, right? No matter I exchange 1 dash 2 dash, it still remains the same. Because from the left side and the right side, it is still the same. So someone said V2 equals to 0. So let me short this and then let us do. So V2 is 0. Okay. If this is the case, then I have to connect a voltage source V1 here, and this is my I1 and this is my I2. So V2 is 0. So we have considered V2 equals to 0. That implies I will get two parameters which are Y11 and Y21. So Y11 is nothing but I1 by V1 and Y21 is nothing but I2 by V1. So I have to calculate this and calculate this. So I need I1 and I2 in terms of V1. Okay. Very simple and straightforward. So how should I proceed? Any idea or any suggestions? First of all, the same thing, whatever I have told, it is always good to proceed with the nodal analysis. Yes, you are right, Roshan Ghosh, because if you see, there are more meshes, but only one node is unknown. So let this be V1. Okay. So first of all, 2 times Ix. So let us calculate this current and let us calculate this current, and this is the Ix. So first of all, I have to find V1. So how many equations are there? V1, I1, Ix, V1, I2. I need I1 in terms of V1 as well as I2 also in terms of V1. Okay. Very simple, straightforward. So first, I'll write all the equations and then we'll use one equation to solve. Okay. And one more thing, this voltage is V1 and this voltage is 0. True? Fine, agree? So first let us apply KCL. Okay. Apply KCL. If you apply KCL, you will get something like this. V1 is, sorry, how soon will this lecture recording be available to us? Can we have it by tonight? Tulasi Manikandan. Actually, the issue is I have to combine these videos, which will take some time, and I have to upload it to YouTube, which again will take some processing. But I will try 90% to upload it by tonight. But if not, then it will be uploaded by tomorrow 10 a.m. But I will try to upload it by tonight itself. Let us see, because I have to combine these videos and then export it. Exporting it will take few hours, and then uploading to YouTube and few post processing will take few more hours. So let us see. I'll try to upload it by tonight. If not, tomorrow 10 a.m. I can promise. So if so, this is V1. So let this be V2 then, because it needs to be a different voltage. So if I apply KCL, we'll get V1 minus V2 by 400 ohm plus 0 minus V2 by 400 ohm plus 0 minus V2 by 400 ohm equals to 0, because uh, this is 1, this is 2, and this is 3. So this is 1, this is 2, and this is 3. So this part is clear. How we are getting V1, V2, V3. Sorry, in terms of V1 and V2. So now I can directly get from this V1 equals to 3V2, or V2 equals to V1 by 3, because I need everything in terms of V1 and V2. So I have got V2 equals to V1 by 3. Clear? Clear? Yeah. So now what will be the value of Ix? So Ix is also unknown. So I will calculate Ix also. Ix is 0 minus V2 by 400. So Ix is nothing but minus V1 by 1200. How V1 is V2 by 3. So if you solve this equation, you will get V1 equals to 3V2 from this equation, because these will get, denominators will get cancelled. All the denominators are same. So the numerator equals to 0, which is V1 minus 3V2 equal to 0, or V2 equals to V1 by 3. Yeah. So now Ix is nothing but 0. This is Ix, right? Basically, this is equal to Ix. So 0 minus V2 by 400. So Ix is minus V1 by 1200. Yeah. So now I got V2 in terms of V1, Ix also in terms of V1. So my problem is more or less solved. So now I'll apply. So let this be called node A, and let this be called node B. So apply KCL at node A. So KCL at node A. KCL at node A. So KCL at node A will give you what? I1 is equals to 2Ix plus this current V1 minus V2 by 400. So I1 equals to 2Ix plus V1 minus V2 by 400. So now I'll substitute all the values. 2Ix is nothing but 2 V1 by 1200, and V1 minus V2 is nothing but 2 V1 by 3, which is 2 V1 by 1200. Agree? Agree? Yeah. So now these two will get cancelled. I will get I1 is equals to 0. If I1 is 0, what happens to my one of the parameter? V Y11. So Y11, let me just copy from here. So my Y11 is equals to 0. So I got my Y11. So that implies my Y11 equals to 0. Now KCL at node B. So if you apply KCL at node B, then what will be the KCL at node B? I2 is equals to current entering equals to current leaving. So 0 minus V2 by 400 plus 2Ix. So I2 is equals to 2Ix plus 0 minus V2 by 400. So 2Ix is nothing but how much? Minus 2V1 by 1200. So minus 2V1 by 1200 plus minus V2, meaning minus V1 by 3. So minus V1 by 1200. So this will be minus 3V1 by 1200, that is equals to minus V1 by 400. So now from this what I'll be getting? I'll be getting Y21. So y21 is I2 by V1. Y21 is I2 by V1, which is, if you calculate, you will be getting minus 2.5 millisiemens. All right, clear? Sir, is there any shortcut to find these y parameters or we have to go by? Yes, there is no shortcut. You have to solve and get this. There is no shortcut or anything as such. Clear? So now we have done for V2 is equals to 0. So now let us see whether we can get V1 equals to 0. So now if you see, say if V1 is 0, magenta. So say if V1 is 0 and V2 you have given V2 and this is I2 and this is I1. So if it is symmetric, the values will also be same, right? Say if I am shorting this side, I got I2 as this, right? Same thing. If I short this side on the short circuit side, I'll get I1 to be minus V2 by 400, which means I will get Y12. I'll also explain it again if you are confused. So let me just write it. So my Y12, my Y12 will be minus 2.5 millisiemens. And wherever I am connecting the circuit, that side I got current equals to 0. So I2 equals to 0, which means my Y22 will be 0. I'll explain if it is a little bit confusing, this last part. So I'll get I2 equals to 0, I2 equals to 0. That implies this is equals to 0. So what I mean to say is, say I have short circuited here and this side there is voltage source, and after the voltage source there is 2ix current, 400 ohm, 400 ohm, 400 ohm, 2ix. If I see from this side, I have voltage source, 2ix down, 400 ohm, 400 ohm, 400 ohm, 2ix and short circuit. So basically whatever this circuit is from this side is the same circuit from this side. So even if you solve for the same equations, what you will be getting is the current that the voltage source supplying I1 is 0. So similarly, the current this voltage V2 is supplying will be 0. And the current in this short circuit I2 is minus V1 by 400. So the current in this short circuit will be minus V2 by 400. So basically both the circuits are same. So you need not do it all over again because this is V1 equals to 0, right? So if you see the circuit is symmetric. So if we have solved for one part, you will automatically get the other part. So if we want to write this matrix y11, y12, we have 0, 0, minus 2.5 milli, minus 2.5 milli, right? So if this is equated, we'll get this is 0 and this is 0 and this is minus 2.5 milli and this also minus 2.5 milli. Because the circuit is symmetric, this is symmetric. And this you will learn in the next week that when will it be symmetric, when will it be not be symmetric. So these parts you'll learn in the next week. But is this question clear? Mainly this part. Because if you
Sir, I
see,
have a doubt that
yeah,
the part
which one?
part one, how did you get the V2, sir? Part one, in part one.
Okay, so
And
this,
here IX,
yeah,
here
sorry,
not.
continue.
Sir, here, when the IX is falling, that the V2 you got, no, sir. How did you get that?
This one. Are you asking about this one?
Yes, sir. In
Yeah.
the part one,
Okay. So if I apply KCL here, the current, this one is V1 minus V2 by 400. And this two part is 0 because I have considered this as ground. Maybe I should have mentioned. So if this is ground, it will be 0 minus V2 by 400. And this is shorted, right? So this 0 is coming over here, 0 minus V2 by 400. So now if you do, it is V1 minus 3V2 equals to 0. So V1 equal to 3V2, V2 equal to V1 by 3. Is that clear?
Yes, sir. I am asking that here node. How did you mention the V2?
Uh, uh, okay, so it is not this V2. I think that was my mistake. So let it be not V2. So let it be some V2 dash. It need not be V2. Say V2 dash, V2 dash, V2 dash, V2 dash, V2 dash, V2 dash. That V2 and this V2 are different. I have just assumed some voltage V2, V2 dash. So fine,
Okay, sir.
because it might
Yes,
be
sir.
confusing.
Thanks.
I understand. I'm sorry for the wrong notation. And this also V2 dash. Yeah. Sorry. I should have used Vx or V dash, but I'm really sorry. Yeah. So now, if this is done, let me just quickly summarize what we have learned today, and maybe I'll solve one or two solutions of week 4 if time permits. So we have Thevenin's theorem. We have seen any circuit can be converted into one equivalent circuit of Thevenin voltage in series with the Thevenin resistor, and we have seen how to calculate those, and we have solved one problem. And we have also seen that for maximum power transfer to happen, RL should be equal to R Thevenin. Now, when we go to Norton's theorem, we have seen that any circuit can be modeled as a parallel combination of one current source. Again, there is a mistake here. So this is current source and a resistor Rn in parallel. And then we have seen how to calculate Norton current and Norton resistance. And we have seen the correlation between Thevenin's equivalent as well as Norton's equivalent. And then we have also seen that how to calculate Norton's equivalent from Thevenin and Thevenin to Norton, vice versa. And then we have solved one problem for calculating Norton current and Norton resistance. And then for maximum power to be transferred, RL should be equal to RN. And then I have given some guidelines so that you can follow this to improve yourself weekly. And then for two-port network, we have talked about Y parameters. Y11, Y12, Y21, Y22, and we have seen for a given circuit how to calculate this. So as this being symmetric, so we have to only solve two parameters and the other two parameters are automatically coming because it is symmetric. So let us just go and see whether they are matching or not. 0 minus 2.5 minus 2.5 0. So 0 minus 2.5 minus 2.5 0. I think they have asked answer in milli, so it will be minus 2.5. So kindly note these kind of mistakes. So if that is said, let me just quickly solve and I'll be solving week 4, right? So let me open week 4 notes. Okay. And then we'll solve week 4 assignment. So how did you do in your week 4? Is everything okay? Hello? Hello?
Yes,
Yeah. So how did you do in your week 4?
I got 60%.
Okay, okay. Good. Have you solved the problems where you have gone or done mistakes?
Yes,
Okay. Were you able to find your mistakes or still no?
yes, sir.
Okay, okay. Yeah, good that you have tried. So let me just talk about. I think I will get time for one or two problems, but before that, let me just talk like the theory that we have covered. So in the week 4, I think we have discussed about the nodal analysis or mesh analysis. Which one? Nodal analysis. So we have covered nodal analysis. So we have seen that for getting the conductance matrix, there is one trick. The diagonal elements are total conductance at the node I, and the non-diagonal elements is the negative of the conductance between those two nodes, and this is the current entering the node. So similarly, if you consider this as a 5 cross 5 matrix, so because how many nodes are there? One node, second node, third node, and fourth node. And this is the reference node. So this is fifth node. So it will be a 5 cross 5 matrix. Agree?
Yes,
Yeah. So now first let us talk about the diagonal elements. So for diagonal elements, At node 1, we have R12, R15, R13. So that's why G15 plus G12 plus Ga13. Correct?
Yes, sir.
And at node 2, we have R25, R22, R23, R12. So that's why we have 4. All the resistances that are connected. And then at node 3, we have R33, R13, R34, R23. So that's why we have again 4. 33, 34, 23, 13. Fine. You're following, right? Hello. If you have any query, please stop. That part is clear.
Okay.
Uh,
Yes,
as
sir.
as these are the assignments that you have solved, I think you will be able to like know where you have made mistake. And I think if you have already solved, you just let me know that you have solved. Or if someone has not solved, then I'll explain. So at node 4, we have R34, R44 only, right? So there are only two. So that's why we have G34 and G44. Now coming to the last node, let me use some different color. So last node is the fifth node where we have R55, R25 and R15. So G55, G15 and G25. So we have this. So diagonal elements are done. So now we'll do the off diagonal elements. So now uh, A12 is negative of the resistor connected in between 1 and 2. So this one and this one. And then between 1 and 3. So 1 and between 1 and 3 we have R13. So G13. Between 1 and 4 we don't have anything, right? So that's why we got 0, because between node 1 and node 4 there is no direct resistance connected, and between node 1 and node 5 we have R15. So that's why we have minus G15. Got it? Now
Yes,
if
sir.
you see between node 2 and node 3 there is R13. So that's why we have minus G23. But between 2 and 4, there is no such direct node as such. So that's why you have 0. And between 2 and 5, if I see, there is one R25 resistance. So that's why I'll get minus G25. Now node 2 is done. Now if I go to node 3, between node 3 and node 4, I have R34. So that's why I got minus G34. Between node 3 and node 5, there is no such resistor as such connected. So it is 0. Now the final one, node 4 and node 5, is there any resistance connected? Nope. So that's why it is also 0. Now if you see, there is one important thing. So if I consider this as a triangle, this will be symmetric. I have told this will be symmetric. So whatever you have obtained there, it will be the same thing. So minus G12, G12. So let me use one nice color. So minus G12, G12, minus G13, G13, and then 0, 0, and here also 0, 0, and this one minus G34, minus G34, and then minus G23, minus G23, and then this 0, 0 is done. So minus G15 and G15, and minus G25 and G25. So that's how it is done. Clear?
Yes, sir.
Yeah. So if you see how many positive elements are 1, 2, 3, 4, 5. So let me go to the question what they have asked. So we write the conductance matrix for the above, find the number of elements with null entries. How many zeros are there? So 1, 2, 3, 4 on this side, 4 on this side. So 8 null entries. And then how many negative entries? And entries more than two conductance terms respectively. So 4 null entries on this side and this. So 8 null entries, and negative are 1, 2, 3, 4, 5, 6 on this side and 6 on that side. So 12 entries. And more than two conductance terms, this is 1, this is 2, this is 3, this is 4. So 4 more than two conductance terms. Is that part clear? Anyone has any queries? Hello? Any queries
No,
in this? Yeah. Okay, no. So now they have given consider all the values of resistance as 2 ohm, and I1 is 2 ampere and I2 is also 8 ampere. Then find 3V1 minus 3V2 minus V3 minus V5. So now this might look a little bit tricky, but if you see that V1, V2, V3, V5. So V1, V2, V3 and V5. So let us see V1, V2, V3 and V5. What is the common thing in between? Say V1 and V2 have R12 common, and V1 and V3 has R13 common, and V1 and V5 has R15 common. So if you see all these nodes, there is one resistor connected in between. So the idea is apply nodal analysis at this. I know this is a very difficult question, and you will not get that idea to apply nodal analysis here. But if you apply nodal analysis, what you are going to get is V1 minus V1 minus V2 by R12. So say the currents are flowing in this direction. Say V1 minus V2 by R12, V1 minus V5 by R15, V1 minus V3 by R13 is equals to I1. So V1 minus V2 by R, V1 minus V5 by R, V1 minus V3 by R equal to I1. And in the question, they have given all the resistors are 2 ohms. I1 is 2 amperes. So if you substitute, you will directly get this expression. Clear? You just have to apply nodal analysis to get this. Is that part clear?
Yeah.
Any queries in this before we move on to
No.
this? Okay. So now if you see in the above circuit, consider all the resistors to be 2K and this. Find the current in the 2 ohm resistor. If you see for any element, KCL should be followed, right? So the current entering, say this is the current. So the current entering should be current leaving, right? But if you see here, there is no written path. Like if you see, there is no written path. As such, say R9, if the current is flowing from this circuit, it will return. But for R2, there is no such return path, right? Like the current is not flowing in, like the current cannot flow in this direction, and there is no return path. Like this entire circuit is a separate part, and this entire circuit is separate part. The current that is entering this circuit is through R2. But is there any return path from this to this part circuit? No return path, right? The only connection is R2. So if the current is flowing from this circuit to this circuit, there should be a path from this circuit to this circuit. So the same current will flow, right? But there is no such part because this current is zero. There is no current coming back from this circuit. Say this is network N2, N1. So the current that is coming from N2 to N1 is zero. So the current that will go from N1 to N2 should also be zero because there should be a return path, right? Whatever current that is coming from N1 to N2 should come to N2 to N1. This is what KCL says, right? So that is not being followed. So that's why this current will be zero. Agree? Simple and straightforward, but a little bit tricky. Agree?
Yes.
Yeah. And if we solve this question, it is also the same. Uh, like at node 1, so first diagonal elements, there how many nodes are there? 1, 2, 3, 4, 5 nodes are there. First diagonal elements, summation of all the conductance at node 1. So at node 1, we have 5K and 5K. So 0.2 milli plus 0.2 milli. How much is that? At node 1, diagonal element, 0.2 milli plus 0.2 milli, because it is 5K and 5K, right? Summation of conductance. How much is it? Anyone? Hello. Brindu Kumar, are you there? Okay. So it is a point 0.2 plus, again, there is less than a minute. If this meeting ends, kindly join. So I'll solve this problem and I'll end today's session. So we have 5 kilo plus 5 kilo, which means zero point 0.4 milli. I hope that that part is clear. Again, if this meeting ends, kindly join back. So I'll wind this session up at this problem. So if we consider at node 2, what resistors do we have? We have three resistors. This one, and this one. So zero point 0.2 plus zero point 0.2 plus zero point 0.2. How much it is? 0.6. So this is done. This is also done. Similarly, at node 3, we have three resistors. So again we have zero point 0.6. At node 4, we have two resistors. So we have zero point 0.4. At node 5, we have two resistors. So we have zero point 0.4. So diagonal elements are done. So now if I come to off diagonal elements, what is the resistance between A1 and 2? So it is 5 kilo. So the conductance will be minus zero point 0.2. So that's why it is minus zero point 0.2. Then between A1 and 3, there is nothing. A1 and A4, there is nothing. A1 and A5 also, there is nothing. So that's why it is 0, 0, and 0. Okay. So now the second row, between 2 and 3, there is, between 2 and 3, there is minus 5k, right? So it will be again minus zero point 0.2. So that's why it is minus zero point 0.2. And between 2 and 4, there is nothing. 2 and 5 also, there is nothing. So all the rest of the elements will be 0 and 0. Now if we come to element 3, between 3 and 4, there is 5k. So it will be minus zero point 0.2. Between 3 and 5, there is nothing. So it will be minus zero point 0.2 and 0. Now if we come back to the other element, which is 4, between 4 and 5, we have 5k, which means it is again minus zero point 0.2. So again, minus zero point 0.2. Again, whatever I have told, the same thing is applicable in this triangle. Whatever is there, the same thing will be in this triangle also, as it is symmetric. So if you see, the same thing is being followed. They have asked sum of the diagonals. So zero point 0.4 plus 0.61, 0.6 plus 0.1, 0.41, 1 plus 1, 2, 2 plus 0.4, 2.4. Is this part clear? Whoever is there, Brindu, Priyanka, and Soman. Basically, it is very simple. At diagonal elements, you have to see all the conductance that is connected to that node and summation of that. If it is off diagonal element, then you have to see between which two nodes we are finding the conductance, and negative of that is the uh, value that we have to enter in this matrix. So once it is done, they have asked summation of the diagonal elements, which is 2.4. So 2.4 is the correct. And now value of the entries in the I matrix. So we have I1, I2, I3, I4, I5, right? So for that, what we will be getting? So for that, currents entering the node, right? So, so what is the current entering this node? 10 plus 5. So this one plus this one, right? So it is 15. Agree? I1 is 15 because 15 is entering. So my I1 is 15 milliampere. Then what about I2? I2, there is no current as such that is connected to the terminal 2. So it will be 0 because no current is entering, which is dependent. So I2, it will be 0. And I3 is bit tricky because current is entering 5 milli and current is leaving 5 milli. So as if no current, there is no current, net current that is entering. So again, this will also be 0. And terminal 4, current is leaving. So that's why it is minus 3 because we need only the current that is entering. So that's why it is again minus 3. And at node 5, 5 is leaving and 2 is also leaving, but we need current entering. So total how much is leaving? 5 plus 2, 7 milliampere is leaving. So it will be minus 7 entering. So that's why it is minus 7 milliampere. So that's how we'll be getting, and it is very straightforward. And I hope most of you have already solved this. Similarly, question 7, 6 also, but as we are running out of time, I will not cover this. Tomorrow, whoever is the TA, she will be covering these questions and solutions tomorrow. Is that clear? Uh, and do you have any queries till this point, whatever we have discussed? These questions, assignment 4, any one of you? Any questions? No questions? Okay, if you don't have any more questions, then we can wind this session today. I hope you have understood the concepts and the problem solving sessions are beneficial for you and you're gaining something from these sessions. If you have any comments, then you can give, or if you have any suggestions, that also you can give. Like if these are being like my sessions are being too fast or too slow, or if you want me to add something, or you can if you want me to skip something, any compliments if you want me to give, like want to give me, then you can let me know. Or if you don't have any compliments or comments, then we can wind this session. Anything you'd like to say or add? Okay, then see you in the next week with week 7. And today we have completed week 6 problem solving session. Okay, see you in the next week. And thank you. Have a nice day. All the best for your week 6 assignment. And we'll meet again in the next week on Monday. Okay, with that, I'll end this session. And thanks for joining.